So what I'm going to do with this lesson is I want to swap between the two GIS notes so that you know, as we're working through the summary, how it correlates to the actual digital notes as well. Because the digital notes act like the textbook. The summary notes are helping you to actually then simplify and consolidate with examples. So if we have a look at the digital notes and we start off on the first page and we look at what actually GIS is, okay? In terms of what it is, the document here is quite important in your summary because it goes over what is the platform, what is the GIS platform. So GIS platform, we can say what it stands for, but that doesn't say what it is. Geographic Information System is what it stands for, but what is it? What it is shown here. It says here it's a framework that we use, or a platform, like a software platform like Google Earth, okay, where we can organize, communicate, and understand our world better because we put data into that system. So in Google Earth, we feed data into it, like satellite images, like where people are located, street layers, altitude, all sorts of information, okay, places, Google photographs, all of that. And all of that data is organized in Google Earth, the platform, the framework, to help us communicate about an area more effectively. So it's not just this flat 2D map that we can't interact with, that we can't customize. So the main thing about GIS is that you are using the data in the system to customize the data to make a map that suits the questions that you have. Questions exist first, and you create a map to answer your questions more effectively. So what you're going to do if you don't have this filled in, which I think you all do, is you're going to follow that YouTube play button and then re-watch that video to fill in all the blank spaces there, to sort of... I think it's not about knowing it off by heart. It's more about understanding it as examples. I'm not going to ask you to quote and rewrite all of this, but if you understand this summary of the video, you understand the sort of why we have GIS, how we use it, who thinks it's useful. Okay. The thing also about GIS is why. The fact is that it helps us to make decisions because we've customized the map so we can decide where's the best place to put something. We can turn certain layers on, turn certain layers off if we don't want to see them. And that allows us, by selecting those layers, it allows us to visualize different bits of information or data that is important for a certain question. Then we turn the layer off and we turn another one on, and then we can answer more questions. Okay. And so I wouldn't learn all of this off by heart, but just to have a general understanding of it. And the main thing is, what is GIS as a framework? How does it work? And how does that link to, say, Google Earth as an example? Okay. You don't need to know the page on Google Earth. When we get to that page, I'll explain to you that just gives the broad kind of history and context of what Google Earth is. But because you're so familiar with the platform, I use the platform to customize a map to then ask you GIS more related questions, not the background knowledge of how Google Earth was made. That's not important. Okay. Right. Then when we look at GIS, the big thing about GIS, because it's information, a system that is organizing information, the information comes in the form of data. Okay. Every single feature on the entire Earth's surface is mappable. So we can see those features because they occupy space, all right, on our landscape. They either occupy a point space, a linear space, or a polygon area space. So if we think about a topographic map, a point like a school is occupying an X and a Y axis location, okay? Or a long road or a river is going to then occupy a linear sort of space on that map. And then a golf course, that's going to occupy a polygon or an area shape on the map. So all of those features then can be coded into a GIS system. You don't need to know the background coding, but you need to understand that data, for the computer to understand it, it needs to understand that it is recognizing it either as a point data form, a linear data form, or a polygon or area data form. Okay. So various things on a map, when we look at a customized map, will either be in point form, like the temperature there, or linear form like the isobars, any kinds of lines on a map. You can think on Google Earth, we can see various kinds of lines, hiking trails, all of that kind of thing. And then you can see that the polygon will be various features like a recreational field and things like that. But remember, on Google Earth, I can also create various shapes on top of features. I can make little lines on the map. I can do all sorts of things that I can add another layer of data on. And generally, when we do color shading, this was the example here, this temperature color shading that's being used here, the color coding, is the actual area data that I was referring to. So where it's more red, that's one kind of area data. Where it's more yellow, that's another kind of area data. So very easy. Color shading shows polygon kind of data. Okay, because how else would you do color shading if you weren't coloring in, right? So if you have a look at that, that's just types of data, the three ways in which it can be in a certain form, and you need to know examples. So if I show you a customized map, you have to think about it. What kind of format is it in? All right. Then, in terms of GIS as a platform, like Google Earth, Windy, these are not real GIS platforms that are like the big paid software out there. That's Esri, QGIS. That's what big companies use, and other companies pay those companies to use their fancy software. But I'm not going to, as a teacher, go and get a license to go and use that fancy stuff. I use the watered down platforms that simulate the idea of GIS. And so when we think of the components are all the things that are needed to make a customized map, a GIS end result map, okay? Obviously, there's hardware. You've got satellites that take the photos initially of the world. We've got ground-based receivers that will take that data. We've got computers. That's all the hardware, right? Then you've got the actual software on the computers that will process all the data and allow you to manipulate the data to make your map. So the Google Earth Pro software that you download onto your computer or your iPad, that's the software. Then you've got the types of data, which I've already explained to you. Then you've got your way in which it can be manipulated. So if I go into Google Earth and I want to specifically show you something, I can start to manipulate that data and interact with the data. And that's the whole purpose, is I actually want to interact with it so that I can customize my map. Okay, so even now, zooming in right now into this location is part of customization. I can add various pins to the map and little shapes. I can turn certain layers on and off. Okay, over here, you saw when I did the river section, I superimposed certain layers on. Okay, we can turn on our various labels and borders. This is Google Earth. Okay, so the satellite image is the main kind of base. Now I've just turned on the borders, the political borders. That's now going on top as another layer. I can turn on the roads or turn off the roads. And obviously the more, there you can see where I got married. So here you can see as I turn that layer on, you are seeing on the beach, you can see there that the roads are then labeled. But if I turn it off, the roads take that layer off. Okay, so that's how I'm manipulating the map. All right. Yeah, that's the fourth one, the fact that you have methods in which you can actually manipulate and play around. Okay? And the users are the people that find this information useful, that might use the application to answer questions and make decisions and do various kinds of statistical analysis. Okay. Now, when we actually get to the Google Earth platform, we need to sense the world first to get that base layer of satellite imagery, all right, to take those photos. And so in order to do that, we use remote sensing. Remote sensing means that you are looking at the world from a distance, like a remote, and you are sensing the world either actively or passively. Now, that means in our notes here, I said I'd show you where it all connects. There's all the extra information about the GIS components if you want to look in detail. Okay, that's on Teams. It's called Grade 9 GIS Basics. And then here on remote sensing, you'll see that I've hyperlinked all sorts of extra videos and information that you can have a look at.
Are you supposed to study it or just like read?
It's for extra background if you feel like you want to get more of a sense of examples out there. Okay, but it's not to go and make notes and learn off by heart. And so with remote sensing, what we also want to look at is that it can happen actively or passively. So if you've got a little picture here like this with the world, sun is shining on the earth. Remember, I explained this in class with the highlighter example. And I said light comes from the electromagnetic spectrum as a form of visible light rays. When that sun shines those visible light rays at the earth, it hits the earth and just passively reflects back off again. And that information, that light information, is captured by cameras. And those are the sensors. And that's a passive process. The camera doesn't send out the light first, then receive the signal back. So it's a passive process. If we look at active sensing, the ones that where you've got sonar or radar, the sonar or radar system will send out the signal first. It bounces off of an object and sends those radio waves or sound waves back again. And then the transmitter or the receiver, is going to receive that signal and make sense of it, digitize it, and map it out. So that's an active process.
So passive is with the sun, and then active
is when it sends its own signal and it's not visible light. It's either sending sound waves or radio waves. Okay. And yet here you can see there's no sun involved. It's communication. So active is communication between the satellite and a receiver, like an object, and then the object. Do you see the arrows sending information back to the satellite? Okay. Here, the sun's involved and it's reflecting off of the earth, and then the camera or the airplane or the drone, whatever's taking photos, will then take photos of that light that's just passively there. Whether the satellite's there or not, the light is going to shine off the earth. Okay? From the dawn of time, we know that it didn't matter whether satellites were taking photos of us or not. But in this instance, if there's no satellite sending a signal or radio waves from a radar transmitter, then you're not going to get that communication. Okay, so that's your difference between active and passive sensing and how it all works. Step 1, 2, 3, 4, 5, 6, you can just run through those because that's in your summary day. Okay. Then what's important to have a look at is that we can take photos and this is obviously then the information that was extra about Google Earth. So I just am explaining here that I use it as a very simplified GIS platform because I can show some of the very basic methods and processes of GIS. Also remember that Google Earth is a global positioning system. It shows us location. So it's giving us geographic information about where we are, all the features of the Earth, where they are on Earth. Okay, so it's not just saying, here's a pretty picture of the Earth, but if I actually look at this feature, I can get a sense of coordinates as well up at the top. And every location, there you can see it's changing the coordinates constantly for every single feature on the whole Earth. Okay, so it's telling us where we are. And there's the south coast, you know, you're going on your way to Port Edward. And it is by sort of the Wild Coast area. This is Leisure Bay. Yeah, you know, Mac Banana, south of it. So Mac Banana, all of that, it's there. The beach is Kids Beach. Very small little tourism town. Okay, so if we go back to our notes, you can read over this to get a sense of how it all works, but I would not learn this page. Okay, this is not useful. No, because it's just the background information of how Google Earth captured all the images. I use Google Earth to create an image for you to then study a customized map to study.
Right. Give us a Google Earth.
Yes, yeah, that's exactly how I'm going to test it. And I integrate it with settlements and with rivers because the whole time I can use both of the theory in both those sections to create the map. So we can not only create the map, but we can also ask the theory around it. Yeah. Right, so the types of data, again, that's just describing it for you, and that every single thing on the surface of the Earth has a longitude and a latitude and an altitude, can be 0, which is sea level, or it can go up, all the way up to the top of Mount Everest. Okay? But what's important is it gives a reference, geographic reference, because every single type of data has an X and a Y axis. If you think of point data, that's got just a point of X and Y. But then with line data, it's like dot to dot, where you connect the lines. So every single one of those dots then has to have coordinates. And then again with your polygon, obviously it's just the line that connects. We're looking at the inside feature, everything that's shaded on the inside. Okay, then that's just why it's useful, various ways it's useful. Then we know that we can take various types of photographs that are useful, and a lot of those photographs are used in geographic information system platforms like Google Earth, but other platforms use them as well to give us even more of a sense of what we're looking at. Back in the day, we'd just get an airplane, take a photo, aerial photo, and there wasn't much to it. Now we can start to tilt the image and start to look at various features in oblique views as well. So when we're looking at it in a vertical aerial format, okay, we know that vertical aerial photos are right above the Earth. Okay, so there it's 90 degrees taking a photo from above, and you're only seeing the tops of the buildings. Okay, if you can see slight sides, that's because you're so close to the surface. But the further you move away, the more you're just going to see the tops of the buildings. Okay. Then when we start to tilt the view, that's when our photographs become oblique. And this is where we summarize all of this in class over here, these examples. And so when we look at oblique photographs, we change the angle that it has with the land. And when it's a 30-degree to the horizon, we know that that is low oblique. We can't see the horizon in the photograph. Okay, no horizon. But you just see the ground, and you see the tops of the buildings, and you see the sides of the buildings. So now you're starting to get the sides showing as well. If I make a high oblique and I do a 60-degree angle, that's when I can start to see the horizon as well. So there I'm seeing the top of a building, the side of the building, and the horizon. If I turn the angle of the camera completely, and I'm now looking at it straight on like side view, then we know that's a horizontal photograph, obviously very useful in street view, okay, to get what the buildings look like along the streets. And satellite is just a vertical aerial photo, can be tilted in different ways. Generally, it's vertical, but it's also from a very far distance compared to the airplanes, and that's that. Right. Then, how do we interpret those photographs? There's 5 main ways that we need to keep these tips in mind. Obviously, the size and the shape is quite important in terms of if the roof is really big, we know that that's not residential. It could be anything that has a huge roof, like a factory, a shopping center. Yeah, exactly. So then if we see a big roof and we now know we've excluded housing, we now need to get other clues around that big roof to try and show us, is it a factory? Is it a shopping center? What other big roofs it could be? I mean, there's lots. Okay.
Like identify.
Yeah. So exactly how I asked it. Exactly. This is like your past paper for this question. So here, exactly how I've done this is exactly what you're going to do in the exam with a different picture.
Okay. Past paper.
This is like a past paper. This is how I'm basically giving this to you as an example question. So what I did is I went on Google Earth to another area, screenshot it, added all the letters, and asked it in the exact same way.
Area that we know.
I don't know all the areas you know. Okay. Right. Then it might, even if it's not an area you know, it doesn't matter, because you don't need to know the area to work it out based on the clues. So if you keep the clues in mind, okay, then you know that that's the easy way to work it all out. The more angular and regular the shape, the more likely it's a man-made object versus natural. The wiggly river, that's going to look very irregular, okay? In terms of pattern, we can see street patterns very easily. And there you start to bring in your theory and you start to think about, and I've also in the theory digital notes given you examples of what Google Earth street views look like and street pattern views. And there you can see, what does a gridiron look like? What does a cobweb? What does irregular? And remember that it's also easier if I turn the street layer on top and I put that layer on top of the actual aerial photo as the base map. It makes it easier for you to interpret the streets. If I turn it off, it's a little bit harder, but you can still see, based on aerial interp, the width of the road, the uniformity of the road, the tone of the road to work out that it's a road. Okay. Tone and shade, that's just, as I said, darker shades, lighter shades. What could it mean? Is it bare ground? Is it actual vegetation? Are we looking at concrete versus tar? That kind of thing. It helps you just to be, basically, these are things that are common knowledge, but it's just reminding you to be aware of them and look at them when you're trying to decode what you're looking at. Texture always helps when you're trying to look at what's smooth, what's coarse. Are you looking at farmlands? Are you looking at water? What are you looking at? And then shadow gives us a sense of either the height of something, if the shadow is really big or really small. It also gives us a sense of whether it's a mountainous feature because it shows the shadow of the mountain along the valley, and it can show you the depth of an excavation. And that's it. That's GIS, ladies. This stuff here is a revision from last year that you don't need to know except for direction. And it's always helpful to know your provinces, but I'm not going to ask that. I'm not going to say label the provinces. It's not a MacBook test. But it is helpful to know your directions, because always in a MacBook exam, not MacBook geography, we always say in the Google Earth image to the south of the map or the northwest or whatever. And if you don't know that, then the clue is not helpful.
And we don't need to know them.
No. No, you don't need to know any of those skills. We were going to add them in. We ran out of time, so we're going to not do that. But just direction is always important. Okay, and that's GIS. It's actually very simple. Are there any questions you want me to answer before I turn the video off? Okay, so let's turn that off.